Finishing out our work in Chapter 4, we are going to be applying what we know to linear functions, to scatter plots and lines of fit. This is the most real-life scenario that these skills can be used for. Here we have 3 different types of vocabulary words. Remember, you can pause the video at any point to write these down. So scatter plots use something called bivariate data. So bi meaning two, variate referring to variables. So it's data with 2 variables. So for example, height versus shoe size, age versus hours of sleep, amount of studying versus grades. So that's known as bivariate data. A scatter plot shows the relationship between a set of data, and there are 3 types that we'll go over later in this video. They are graphed as a set of ordered pairs on a coordinate plane. Most of the time, these are not going to be in a straight line. They are going to be in a line-like pattern, but as the name alludes to, some of them will be scattered. With that, we can make a line of best fit or a line of fit. For when the points are graphed close together, they'll fall on a line, sort of, that represents the data. And a line of fit can be made. This can be used to represent the data and can be helpful in predicting a trend. And we'll do this a little bit later with an example. As I just mentioned, there are 3 types of scatter plots that we can see, 3 types of correlation. So correlation is talking about relationships. So in a positive correlation, just like as a positive slope, as x increases, y increases. Same thing with negative. It's going to look like a negative slope on a line. As x increase, y is going to decrease. And when you have no correlation, x and y are just scattered. And it's really important when you are making a scatter plot to have the correct scale, because sometimes things can look like they have no correlation because the view is not correct. And so we will work on identifying what might be a good scale to use when we graph our example. Here is an example of the hours someone works and the money that they make. So we need to determine whether this graph shows a positive, negative, or no correlation. If there is a positive or negative correlation, describe its meaning for this situation. So you guys can see the x values, the hours are increasing, and the y values are also increasing. So this has a positive correlation. And what it means is that the longer you work, time-wise, the more money you will make. That should say you, not your. The more money you make. So it is true that if you work more than 40 hours in a week, you are going to probably, based on this data, make more than $600 for the week. So how can we do the scatter plot and line of fit? We are going to use this linear function to model data. So step 1 is to actually make a scatter plot, and it's really easy. You are just graphing a set of points on the coordinate plane. They're going to be throughout, and there's no real art to it. It is just graphing x and y values on your coordinate plane. Then, once we do that, we determine whether any relationship exists between the data, and we will be able to see that in our graph today. From there, we can make a line of fit. Remember that lines of fit are made to help us determine predictions. So we want to draw a line that seems to pass close to most of the data points. So you'll see I'm going to draw a line in the middle of the data. it should pass through at least 2 data points in order for us to be able to make a line of fit. We need 2 data points. So we use 2 points on the line to make a line of fit. And we can use the line of fit to predict outcomes. And as you get further into statistics, you will be able to tell if that line of fit is accurate or not based on some other factors, and using a calculator, a digital calculator, is really helpful for that. But for now, we are just doing this by hand on our own. Okay, so on the bottom of page 42, you have a set of data. This data shows the largest vertical drop of 9 roller coasters in the US and the number of years after 1988 that they were opened. And so in your data here, we have years since 1988 and the vertical drop in feet. So we are going to make our table. Here is a good chance right now to pause and make sure that your table, your graph, scale values match mine. And we're going to talk about them here in just a moment. Okay, so I looked at my data and I looked at the size of my graph and knew that I had between 2 and 12, about 12 pieces, 12 lines that I could use. So I said my highest data point was 15. I'm going to go up. I could have gone up by 1s. I would have run out of room. So I just decided to go up by 2s on my x-axis. On my y-axis, I looked at my highest value and my lowest value. I knew that my highest value was 400 and that my lowest value was right around 150. So it is legal for you to start your first line at 150 as long as when you do this, and I haven't done it yet, you take your pen and you show that there's this little kind of zigzag. That tells you that there's an entire part of the graph below this that exists that you can't see because there's no data there. So it doesn't just start at 150, it starts at 0 and it goes all the way up to 150, but we just took out this chunk right here, we cut it out. And so that little zigzag that I just talked about here, which you'll see right in the bottom corner, helps to show that that's what happened. So from there, I looked and said, okay, I need to go up to 400. So I went up by 25s. This will just take practice, getting used to choosing what values work and some trial and error. I've been doing math a very long time, so I have a pretty good understanding. You're going to do this sometimes and maybe you'll make a mistake. It's okay, because you can go back and try again. So I'm going to graph my points here, and I am going to show you a couple. I'm going to pause my video feed, and then I will let you get caught up and do this yourselves. Okay, so you're going to see my pen on the screen start graphing. I know that 1 is not exactly on a line here, and 151 falls just above it. Estimate the best that you can. So 3 would be at about 155, which is just going to be slightly higher. 5 goes up to 225, which on our screen here and on your graph is going to be in between 4 and 6, but falls directly on a Y line, and so on and so forth. So you're going to see here in just a minute that this will populate. Okay, so by now, hopefully you can see that all of the dots are now on the screen. They do not make a straight line. However, they do form a positive relationship. So that means as the years past 1988 happened, the vertical drop increased in the roller coasters. We are going to, in the next slide here, and in the same spot on your page, we are going to make a line of fit. So you're going to need a ruler for this. All right, so you should have your ruler, and we are going to draw a line of best fit. We have to know that no line will pass through all of the data points, so we want to make sure that they go through as many points as possible, but they need to include 2 of them. So here is an example of what I did. I used the point, the x value with 3 and the middle 12 value. So I am going to try my absolute best here to do this without having access to a ruler at the moment. So I am going to take my pen and start drawing my line. It's not straight, but you get the picture here. Because algebraically, I am going to write my line of fit. Ideally, this would be done with a straight line. So I have my 2 points that it went through. And over here on the right-hand part of my screen, I am using 3 155 and 12 300. I'm going to find the slope of these first. So 300 minus 155, all divided by 12 minus 3. When I do that, and I've found the slope, I get 145 over 9, which reduces to roughly, and please round here, mine reduces roughly to 16.1. It is okay if you get a random decimal, because this is not exact. A computer can do this exact. You are not a computer. So round to the nearest tenth, round to the nearest whole number. It is okay if they're not exact. So from here, I'm using 16.1, and it's actually 16.1 repeating, so I'm just going to use that, 16.1. And I'm going to put in my point. I'm going to use 300 for my point. So I'm going to use y minus 300 equals 16.1 times x minus 12. I'm going to distribute. That's going to give me y minus 300 equals 16.1 x minus 16.1 times 12, which is 193.2. Okay, I'm going to add 300 to both sides. I've run out of room here, but my equation is y equals 16.1x plus 106.8. And so they want us to know to use our line to predict the vertical drop of a roller coaster 30 years after 1988. And so I'm going to use 30 as my x value. So I'm going to multiply that by 16.1 and then add 106.8. So when I do that, I get the following value. 589 feet and roughly 589 feet. So as you can see, this is only one way to do it, and you're going to be dealing with decimals, and that's okay, because you can use a calculator to help you as you are doing it. Remember to ask questions if you need help.